So, good afternoon, students. From the last 2 3 classes, we were having some network issue, and that is why we were not able to take the class. So, today, now that problem has been resolved, and now that is there. So, we will be starting from the point where we have left. Although I have discussed about the normal distribution, and then we were about to discuss the properties of normal distribution. But being a gap of some days, today I will be starting with this normal distribution of fresh. So basically today, one more thing that I will be taking attendance in between the lecture also. Okay, so what you have to do is simply you have to write your roll number and post it in the live chat. Okay, but that thing you have to do when I will be telling you. Okay, not before that. So I will be checking that who are the person those are listening to the lecture online or not. Okay, and that will not be like this that okay, now you mark your attendance. I will be asking randomly from any number to any number, roll number. Okay, that is you have to mark. Okay, so we will see that any batch I can ask that first the B batch now mark your attendance, or C batch now you mark your attendance, and then I will tell you with the what you have been added online, and then accordingly you will be given attendance, because it has been observed that many students do not confine to the listening of the lecture, and it becomes very difficult later on to understand from the your videos available on the YouTube, because here when you are here in the lecture you can ask question, and accordingly your queries can be resolved simultaneously. Otherwise there is no point of taking the live lecture. We can make a video and upload it on your YouTube. Okay, so starting today, so normal distribution, this I have already told you that normal distribution is a continuous probability distribution. Okay, and this distribution is important because most of the parameters measured on a continuous scale follow this distribution. Okay, so basically what you need to understand is that any parameter which is continuous in nature and which are most of the traits of economic importance, okay, they follow the continuous probability distribution. Okay, and that is why this distribution becomes very important. So this is what I have highlighted here, that most of the traits of economic importance are continuous in nature, and hence they follow the continuous probability distribution. So this was discovered by Abraham D. Mowbray. This we have already discussed, and what he was doing, and he was actually mathematically calculating that what is the probability of getting 60 or more tails out of the 100 coin flips. And when he plotted that probability, he found a bell-shaped curve, and he referred to it, which is normally being referred as a norm. Okay, so that was about the discovery of this normal distribution. Now, this some other scientists also has these observations, like Lambert Quetelet. He was a Belgian astronomer, and he noticed the link between the weight and height distribution in the normal curve. Similarly, many of the scientists were analyzing errors in the measurement, and they also find that these errors, when you plot on the graph, they were found to be symmetric in nature. Okay, some of the errors are having maximum frequency, some very less. That is, the errors, the mean of errors having the maximum occurrence in the errors in measurement. Okay, and those far apart from the mean, either very high or very low, they have less probability of occurrence errors. Okay, then there were some other scientists like Adrian and Gauss, those developed the formula for normal distribution. Okay, and one Laplace was there who has given a influential central limit theorem. What this theorem says that let it there be any population there, and it is not following a normal distribution. To take out the samples from it, for each sample you calculate the mean, plot those means on the graph. You will find a bell-shaped curve of those means. Okay, that is a sample means drawn from a non-continuous a distribution which is not following a normal distribution becomes normal. Okay, that is you take out the samples, take their means, plot them, so it will again become normal. Okay, so here we had to start today. So this was about the introduction about the normal distribution. So what are the properties of this normal distribution? Okay. So the mathematical equation for the normal distribution was given by Abraham de Moivre in 1733, and it is also known as Gaussian distribution after the name of Carl Friedrich Gauss, who independently derived its equation from a study of errors in repeated measurement of the same quantity. Okay. So in statistical theory, the probability distribution of a continuous variable can be expressed in the terms of probability density function. And what is that probability density function of a continuous variable? That is equivalent to 1 upon sigma square root of 2 pi multiplied by e power minus half multiplication of x minus mu, where x is the random. Okay, I think we are now able to get connected. If you are able to hear me, kindly reply that. Are you able to listen?